If you smack two heavy metal balls together, the energy of their collision will be focused at such a small point enough heat can be produced to literally burn a hole through paper. Try this at home. It smells like smoke, but let's make it even hotter. First, I'll need to rust up one of these balls. A bowl of water should do the trick. 10 days later, that's a rusty meatball. We'll wrap the other ball in aluminum foil, turn down the lights, put on some ear and eye protection, and start whacking until this happens. Did you see that? That is molten slag at more than 4,500 degrees Fahrenheit. Now that didn't happen because I'm so strong, even though I am. It happened because the colliding balls produced the ignition temperature needed for a thermite reaction. The aluminum reduced the iron oxide, the rust on the ball, to form aluminum oxide, elemental iron, and much more heat than I put in. Now that's what I call exothermic redox. Can you draw this without ever lifting your pen off the paper? Probably not, but I'm going to show you how. I love this trick. When I was a kid, I showed this to everyone, and they thought that I was not weird. Here's how you do it. Grab a sheet of paper and a marker. Begin with the dot. Now maintain contact with the paper and stop thinking in 2 dimensions. Grab the corner of the page and fold it into the dot. Now, while maintaining contact with the paper, move on to the back of the page, come on up here, come back onto the front of the page, fold the paper flat, and complete the ring. Can you draw? Let's make some Gallinstan. Unlike mercury, Gallinstan is not toxic, and it's a liquid at room temperature, unlike gallium, which is solid up until about 30 Celsius. You have to hold this for a while before it starts getting drippy. No. You deserve a metal that is almost always wet. I'm gonna need this magnifying sheet. It's a bit floppy, but I can just whip out my tools and build it a sturdy frame. The lens can focus the sun's energy enough to easily melt tin. And that's great because by weight, Gallinstan is 10% tin, 20% indium, the only element you can safely chew like bubblegum, and 70% gallium. To speed things up, I used my lens to melt the metals down. They began to amalgamate. Their respective atoms all get in each other's way, frustrating crystallization, so instead of melting at 232, 156, or 30, Gallinstan melts at just 11. I froze some gallium and some Gallinstan in my freezer, and watch this. After just a few minutes, the gallium was still solid, but the Gallinstan was a nice, shiny mirror soup. Let's make 6, 5, 4, 3, 2, 1. Why don't we ever learn about digons and monogons? Well, it's because they're impossible, right? No. Real eyes realize that you and I walk around on digons and monogons every day. But Big Flat tells us that 2 straight lines can only meet at no points, 1 point, or every point. A digon, a polygon where 2 straight lines meet at 2 points? That could only happen if the line's curved, then it wouldn't be a polygon. But what if the lines don't curve? What if instead the space they inhabit curves? This line is straight. A 2-dimensional observer would agree that it never turns, but unbeknownst to them, the line does curve into a higher spatial dimension beyond their comprehension. Add another straight line sharing those vertices and you've got a spherical loon, and it's a true 2-sided polygon, but it's only possible in spherical geometry. On top of that, the hemisphere you live on is a monogon, a 1-sided polygon. Its one and only side is any spherically straight line you can draw on the globe, a great circle. 6, 5, 4, 3.
If you haven't changed your browser,
if you spell drawer backwards, you get a reward. But if you spell repaid backwards, you get a diaper. If a word doesn't change when its spelling is reversed, we call it a palindrome. But if, when reversed, it becomes an entirely new word, it's not called a palindrome, it's called an amordnalap. And this is my amordnalap palindrome machine. When it comes to wordplay, I am an avid diva, but I've never really been happy with my demonstrations of them. They're always kind of messy. For years, I've dreamt of a way to reverse physical letters with just one clear motion that doesn't also flip the letters upside down. Now, my first idea was a kind of Ferris wheel with weighted letters that always hung right side up. But I was not about to ride gravity's coattails on this one, not for something this personal. So instead, I devised a toothed solution. Notice that when connected like this, these larger gears all turn together. Now that means that if I keep any one of them oriented how I want, the others will stay that way too. I was getting close to finally realizing my dream of showing with a single, simple flourish that, for example, Margaret would be a beautiful name for 1 billion kilograms of mass. The next problem was figuring out how to stick these magnetic letters on the plastic gears. Glue, maybe tape? Get real. I want something that makes me say, wow. I don't want the gears to get all sticky and messed up, and I want easily switching letters to be a challenge that can be won now. So I decided to use some magnets I found in a tube that said don't touch. They were so strong, they could stick on by just tugging each other across a gear. But I needed clearance in the back for that to happen. Luckily, a single double bushing was all it took. Speaking of double, if you're expecting twins, why not give them a pair of names that are amordinolaps, like Cassie and Isaac, Noel and Leon, or Iris and Siri. Oh, and also Harper Lee's first name, Nell, was given to her in backwards honor of her grandmother, whose name was Ellen. When it was all done, I finally had a contraption that could demonstrate amordinolaps that were as sweet as desserts without getting stressed. I could also remind people that if a leveler does a bad job, they will be asked to re-level. Ultimately, I put 11 gears on my machine, which is enough to spell abophobia, the fear of palindromes. If you spell drawer backwards, you get a reward. But if you spell repaid backwards, you get a diaper. If a word doesn't change when its spelling is reversed, we call it a palindrome. But if, when reversed, it becomes an entirely new word, it's not called a palindrome, it's called an amordinolap. And this is my amordinolap palindrome machine. When it comes to wordplay, I am an avid diva, but I've never really been happy with my demonstrations of them. They're always kind of messy. For years, I've dreamt of a way to reverse physical letters with just one clear motion that doesn't also flip the letters upside down. Now, my first idea was a kind of mirrors do not show us a fourth dimension, but they do show us what a fourth dimension could do to us. First, notice that some things are the same as their mirror image, but some things are not. These two shapes are similar, but they cannot be rotated to look identical, to be superimposable on each other. This is called being chiral. A chiral shape and its mirror image are called enantiomorphs. These two shapes are enantiomorphs in 2 dimensions. No amount of 2-dimensional rotations will ever make them superimposable. To do that, I'll need to smash one of them inside out, turn it into its own mirror image, or rotate it in a third higher dimension. If I place a sticker here and face that side away from me, notice that the mirror inverts the object just like a rotation through a higher dimension can. The side of the real object that's furthest from me becomes the side of the virtual object that's closest to me. So what would I look like if I was rotated around a plane in a 4th spatial dimension and then brought back? I would look like that. Mirrors do not show us a 4th dimension, but they do show us what a 4th dimension could do to us.
What are you doing this Sunday?
If you applied a coat of paint to the bottom of your shoes every single day, one coat on top of the other every morning, you would leave Earth just as quickly as our moon is leaving us. Every day, the moon moves about 1/10 of a millimeter away from Earth. It's 3.8 centimeters further away from us every year. That's about the length of an AirPod. The moon is leaving us because the world is turning. The moon's gravity causes the Earth to slightly bulge, but because the Earth rotates in the same direction as the moon's orbit, the bulge tugs on the moon, speeding it up. And the faster something moves tangentially to a gravitational pull, the more successfully it escapes that gravity and the further out it orbits. The moon's equal and opposite pull on the bulge slows down Earth's rotation. And if the Earth and moon survive the death of our sun 5 billion years from now, 45 billion years after that, they will be tidally locked to each other. For half of the Earth, the moon will appear permanently fixed to a point in the sky, and the other half will never see the moon again. If you